Hello everyone, this is Seema here. In this session, we are going to learn about System Verilog Test Bench architecture. So here comes the diagram of System Verilog Test Bench architecture. So this is the most important and the basic question that is asked in every interview. Now, let us understand about this concept. So, let me first divide this concept into three main points. First point is hierarchy. Second point is, let me make you people to understand about the functionality of each and every file here. Third point, I will explain about the connections, how exactly we are going to make the connections between these files. Now, the first point comes hierarchy. So we have top, inside top we have test bench and DUT. Inside test bench we have test, inside test we have env, inside env we have some other files like transaction, generator, driver is also called as bus function model. We have input monitor, output monitor, we can also call it as write monitor, read monitor, and followed by that we have scoreboard. Basically, inside the system Verilog test bench architecture, all the files are dynamic, which means what? Each and every file here, for example, the monitor, the driver, scoreboard, generator, all of these files are class based. Whereas the DUT is a static, so the DUT is obviously written in module. So there is a difference here. So our test bench architecture is a dynamic, whereas the DUT is a static. Okay. So now let us try to understand what is the use of transaction, what is the work of generator, what driver is doing, what is the work of monitor and the scoreboard. Now in the transaction we are going to declare the signals that must be randomized. And why we randomized, what are the types of randomization present in system Verilog, we are going to discuss that in a separate session. But as of now, I'm just going to give the overview on this particular concept. So let us continue. So in the transaction, we are going to declare the signals that must be randomized, and we are going to implement the constraints, post randomization, etc. So basically in the transaction file, we are going to implement the randomization concept, which we are going to study it in a further classes. Now, in the generator, we are going to randomize this transaction. So transaction is nothing but a data, or we can also call it as a packet, right? So the data is been, the logic of the data is written here, that data is been randomized in the generator by calling the dot randomize method. So all over, randomization is a separate topic which you will be learning in the further sessions. Okay. Yes yes So here basically the transaction is nothing but the data, or we can also call it as a packet. So here in the transaction we are actually writing the logic for the data. That data is randomized in the generator. So the work of generator is to randomize the transaction and send the transaction to the driver. How? Via mailbox. We have some concept called mailbox. With the help of the mailbox, we are going to send the data, which means the transaction. We are going to send the transaction from the generator to the driver. I repeat, in the generator, we are going to randomize the transaction, and we are going to send the transaction from the generator to the driver with the help of mailbox. Now let us understand what is the work of driver. So driver is basically collecting the transaction from the generator, and it is going to drive the transaction to the DUT via interface. So here we have to be very careful in the explanation. Driver is going to get the transaction from the generator via mailbox. The same driver is going to drive the stimulus or drive the data or drive the transaction to the DUT with the help of interface. So basically here what happens, whenever we are doing the communication between the test bench component, we are going to use the mailbox. Right, we can see here, whenever we are doing the communication between monitor to scoreboard, output monitor to scoreboard, generator to driver, we are using the mailboxes. But when we are communicating between the test bench and the DUT, we are going to use something called interface. So this is something that we have to make a note of. So basically here what is happening is the data, the packet or the transaction is getting converted from the packet level to the pin level of data, because test bench is capable to understand the packet level of transaction, whereas when the same data we are sending to the DUT, then DUT cannot, has DUT is a static and it cannot understand the packet level of data. So automatically the conversion will happen from packet level to the pin level. Now, so the driver is going to send the data, or driver is going to send the packet from the driver to the DUT. Now in the DUT there is some DUT logic or there is some RTL logic where the sampling will happen, right? And the output is again driven back to the output monitor. So driver is going to send the data, driver is going to send the transaction from the test bench to the DUT, just like how we are passing the stimulus, right? In the Verilog, we are having one test bench, right? So in the test bench, what we are doing, we are going to write the stimulus. We are going to write the stimulus in the test bench of the Verilog, and we are going to pass that stimulus to the RTL logic. Here also we are doing the same thing. Here driver is sending the driver is driving the transaction to the DUT, right? Nothing but the stimulus, we are driving the stimulus to the DUT. So that stimulus is been sampled here, so the logic is been simulated here, and then the actual DUT output is again driven back to the monitor. So here what is the work of output monitor? Output monitor is going to collect the data from the DUT. Here once again the pin level data is getting converted into the packet level of data. Again the same reason. So whenever you have a dynamic environment, the dynamic environment is capable to understand the packet level of transaction, whereas the static level of components are able to understand the pin level of transaction. Now, so as we understood what is the work of output monitor is going to collect the output, the actual DUT output from the DUT, and it is going to drive that to the scoreboard. Now that is about one particular transaction. So now let us understand what is the work of this input monitor. Well, so far as I have told, the driver is going to drive the transaction to the DUT. So in the DUT the sampling process will happen. Again from the DUT we are going to drive the data to the monitor. So monitor is going to collect the DUT output and it is going to send to the scoreboard. Fine. But what is the work of the scoreboard? So basically inside the scoreboard we are going to write the comparison logic. So what exactly we are going to compare means, so anyways in the DUT we have driven the data, we have got an output, that is an actual DUT output. So that data anyways it is sent to the scoreboard, but along with that as a programmer we have to generate the reference output or expected output, right? So how do we generate the expected or the reference output? With the help of input monitor. So now what is the work of input monitor? Input monitor is going to take all the stimulus from the driver. Basically driver has driven the stimulus to the DUT, or driver has driven the transaction to the DUT, right? So now the same signals is been collected by the input monitor. Okay, but input monitor is not connected to the DUT. Please do remember that output monitor is connected to the DUT. Output monitor is actually collecting the output from the DUT, but not the input monitor. Input monitor is collecting the stimulus from the driver, and here we are writing the logic in such a way that we are going to get an expected output or the reference output. Okay, because we need some reference. whatever the output we get from the DUT, we cannot give the conclusion as okay, this is the final output. No, we need to compare that with an expected output that we are going to generate, right? So if we want to generate the expected output, we need the stimulus, right? So we are going to collect the stimulus from the driver, and we are going to create we are going to generate the reference or the expected output, and again we are going to drive the data to the scoreboard. So now in the scoreboard we have two output, one output which output monitor is been driven, and another output which is called as reference output, which input monitor has been driven. So now the comparison in the scoreboard, the comparison will happen between the reference output and the DUT output. And if the comparison is successful, then the project is successful. If the comparison is failed, again we have to check back with the logic. So this is the functionality of each and every file of this architecture. Now, as I told, the third point will be of connection. So, whenever we are doing the connection between the dynamic files, which means what? Whenever we are doing the connection between the components of the test bench, then we are going to use mailbox. So, from generator to driver, driver to input monitor, output monitor to scoreboard, input monitor to scoreboard, everywhere we can see wherever the connection is happening inside the test bench, we are using something called mailbox. So again, mailbox is a separate topic that we will be studying in the further sessions. So that's about the mailbox. But when we want to do the communication out of the test bench, so this is our test bench, right? So out of the test bench, when we want to do the communication, we are supposed to use interface. Now you people can have one question, that is, why can't we use interface inside the test bench also? The answer is, the DUT is a static component and the test bench is a dynamic. So interface is also the static one. So I can't use this static interface inside the dynamic environment. So I'm going to one concept called mailbox. So mailbox is a dynamic concept. So that is why mailbox is used inside the test bench and interface is used outside the test bench. So this is about the system Verilog test bench architecture. Now let us just go through some of the basic files of transaction, generator, monitors, drivers and the scoreboard, and let us just understand how exactly we are going to frame the architecture. We are not going to write any logic inside that, but we are just going to understand how the hierarchy has been developed. Yes. So as I told, here we can see the basic files. So far in the system Verilog architecture, we have seen DUT, test bench, test, ENV, monitors, driver, scoreboard, generator. So all this file, the basic outline I'm going to show now. Yes. So here comes the design code. Design code, as we all know, it's a static one. So we are going to write inside module and module, right? We have something called interface. As we have seen in the diagram, interface is a communication mode between the TB and the DUT. So we have a separate concept of interface where we are going to learn about how exactly we are going to write the code for interface. Inside interface, we have something called clocking block and mod ports, which we are going to separately study in another session. Now, so interface, if we want to write the file for interface, we are going to write that inside interface, end interface, followed by the interface name, and optionally we can keep the clock. Inside the top, we are going to include all the files that we have created so far, because even in the architecture diagram we can have a close observation that inside the top you have all the components, dut, interface, test bench. Again inside test bench we have test, env. Again inside env we have a number of files. So all those files must be included here, and we call this as package. It's not like we have to write a package file separately. If we are willing to write a package file separately, yes, we can write it separately, or in the top module itself we can just include all the files here. And here the order is very important. So first comes dut, then interface, then transaction, then generator, driver, monitors, scoreboard, env, test, and test bench. So this order is very important. Now inside the top module we have to instantiate three things. One is the interface file, one is the test bench file, and one is the dut. Once again, if we go back to the architecture diagram, inside the top again we have test bench, interface, and dut. So that's why we are going to instantiate these three files. Even if we check the Verilog files also, when we are writing the test bench for the Verilog, just by writing the stimulus it is not possible for us to make the connection between the RTL and the test bench. See, there is an RTL file, there is a test bench file in the Verilog, right? Okay, we are writing the in the test bench we are going to write the stimulus, but just by writing the stimulus, is it like it is it going directly to the, is it reaching the RTL code directly? No, we have to build some connection, because RTL is some file, test bench is some other file. We have to create some connection between both the files, right? So how are we going to make the connection? With the help of instantiation. The same procedure we have implemented here also. In the top you have three files. So three basic blocks, three main important blocks, that is interface, test bench, and dut, right? So we have to instantiate that, right? Then only it is possible for us to create a connection between this block. So this is very important. Next, we have a test bench. So program and program, we are going to write the test bench. Inside that we can instantiate once again the instance of your interface. So basically we call this as handle, so which we are going to learn in OOP concept in the further sessions. And we have a test, class and class test. So basically in today's class I'm not going to explain anything with respect to the logic. So I'm just explaining about the hierarchy, how exactly the files are been written, the basic outline. And in the environment, as we already know, inside the environment we have generator, driver, scoreboard, and the monitors. The same thing we have written here, right? So inside the environment we have all these components, or we have all these files. So we are creating an instance of that here. Okay. And so inside the transaction file, as I told, we are going to write all the signals that must be randomized. So as of now, I am not writing anything. I'm just showing how the class, how the files are been declared. So which file is declared in the module, which file is declared as an interface, in which file we have to do the instantiation, right? So these are the basic things that I'll be explaining in this class. In the coming session, we will understand more about how exactly we are going to write the transaction file, how we have to randomize in the generator, what is the mailbox concept, how many inbuilt methods are there in mailbox. So all these concepts we are going to learn in the further session. As of now, we are only going to concentrate on the test bench architecture only. And in the generator, same class and the generator name. So in the generator, as I told, in the transaction class, whatever the data is been written, the data is getting randomized here. So the logic is not written, the logic will be written in the further session. After the generator, the data is been sent to the driver. How? Using the mailbox. From the generator, the data is been sent to the driver. From the driver, we are going to send the data to the DUT via interface. Again, in the input monitor, output monitor, the same thing. We can see we have just declared it as class and class. As I discussed even in the diagram, all the files in the test bench architecture are declared as class. And Finally, the scoreboard is also written in the class. So this is how the outline of the class based code is been declared. So first comes DUT, it is in module. Interface, we are writing inside interface, end interface. Inside the top, main importantly, we have to include all the files using tick include. The order is very important, and inside the top we are going to instantiate three things, three files. And in the top we are going to instantiate three files, that is interface, test bench, dut. And and then comes the outline. So in the test bench we are going to write program and program. For the test environment, packet, I mean the transaction, generator, driver, monitors, and the scoreboard we are going to declare as a class. Or all these files which are coming inside the env are declared as class based codes. So that's how we can tell the system verilog test bench architecture is dynamic, nothing but we are writing the code in the class based style, and the dut is a static as it is written in a module. So I hope you have understood the concept. So basically, this whenever someone is asking what is test bench architecture in system verilog, we are going to divide the answer into three steps. One is the hierarchy, second will be the functionality of each and every file, and the third point will be the connection. So this is how the answer should be framed. Yes. Thank you. So let us meet in the next session.